Hello everyone, welcome to my YouTube channel. In the lecture of class 11th, today I will solve the exercise 4.1 of ncert. I have told you about the first type of mathematical induction, first type of the statements which you have to use by step by step by taking principle of mathematical induction. That first 17 question are of that type which I have explained in my previous lecture. Now I will solve the second type of statements which I have from question number 18 to onward 24 questions. That is the second type of the statements which I have to prove by using the principle of mathematical induction. And how we can solve these questions? So I will start the question number 18. This is 18 question of your ncert 4.1 exercise 4.1, and the 18 question is there is not a equality sign in between them, there is a less than sign. By using the principle of mathematical induction you have to prove it. How we can solve it? Again we have 3 steps to solve it. First is you have to prove it for n equals to 1. Okay, in the second step you have to take n equals to k. The third and the important and more scoring step, that is the step number 3rd, in which you have to use the step 2nd for proving the step 3rd, that is for n equals to k plus 1 you have to use the step 2nd, that is n is equals to k. How you can use, how you can solve? So let's start with the question. My question is here and I will solve the answer by taking put n equals to 1. When you put n equals to 1, you have to choose this. 1 is less than 1 upon 8, 2 1s are 2 plus 1 whole square. 1 is less than 1 by 8. This is 2 and plus 1, that is 3. 3 3s are 9. So it will equals to 9 by 8. Yes, 9 by 8 is more than 1. So true for n equals to 1, right? Now assume the results. This is step 1. Step 2, assume the result is true for, the result is true for n equals to k. This is a very simple step. You have to just replace n by k by using 1 plus 2 plus 3 so on, plus k less than 1 upon 8, 2k plus 1 whole square. For finding the k plus 1, for satisfying the equation for k plus 1, you have to add. The last term should be k plus 1 in this place. So to prove for this result, we have 1 plus 2 plus 3 plus so on k, and the last term should be k plus 1. This whole term, that will you have to add k plus 1 on both sides like this. 1 upon 8, 2k plus 1 whole square plus k plus 1. That term which you have added in left hand side, you have to add in right hand side both. Now we have to simplify it and reach at the result. What is that result? I will put in rough work, I will put k plus 1 in place of n like this. 2k plus 1 plus 1 square, that means 1 upon 8, 2k plus 2, 2k plus 2 plus 1 whole square, that this is 1 upon 8, 2k plus 3 whole square. So I want this result. If this result is prepared here, that means the result is true for n equals to k plus 1. Okay, so let's start with the third step. Let's solve for this result. So what is the result by solving? We have 1 upon 8. When you open it, it will equals to 4k square, a plus b whole square, a square plus b square plus 2 to the 4k plus k plus 1. When you take the LCM, it becomes 8k plus 8, right? Now 1 upon 8, when you take the LCM, it will 1 upon 8, 4k square, there is nothing, 4k square plus 4 and 8, 12k plus 9, is it right? Now if I open this 2k square, this is 2k whole square plus 3k square, I will draw from this side For the third step, I want in the next step we have 1 by k. This is 1 plus 2 plus 3 k plus 1 less than, that is 1 upon 8. 1 upon 8, and in this place we can write it as 2k square plus 2ab, that is 2k into 3 plus 3 square. This is the rough work. Okay, so this is 3 square, 2k whole square plus 2 to the 4, 4 3s are 12k plus 3 square. So I will write it as 1 upon a 2k plus 3 whole square. So this match with the given rough work. This is the result. This means that the result 1 plus 2 plus 3 plus so on k plus 1 is less than this value. It is true for, this implies the result is true for, n equals to k plus 1. Then by mathematical induction, the result is true for all n. Result is true for all n. So this is the way to solve this question. This is the end of this question. I have write this step to understand when k plus 1 is added in this step. In the third step, when you add for k plus 1, you have to add the same term on both sides. When you take the number on both sides, so you have to open this term a plus b whole square by taking the LCM also. It will equals to 8k plus 8. Add this 4k square, add these two because k and k, 8 and 4 12, 1 and 8, that is 9. Open in the form of formula and write the formula. Yes, this is the result. Okay, now come to the second type, that is question number 19. Here we have left and right side is given. Inequality, there is also the left and right sides are given. Here, because in the case of inequality you have the left and right side. But in some question, when the polynomial is there, there is no left and right side. Okay, there is only a polynomial and you have to prove that n, question is n plus 1, n plus 5 is a multiple of, you have to show that it is multiple of 3. Okay, you have to prove this result by the mathematical induction. It is told to you in the exam that you have to solve it by the mathematical induction. Okay, for mathematical induction you have to take it as a polynomial in the form of n. You have to suppose, because there is no left, no right hand side, so you have to take it as Pn. So how you can take it as, this is Pn. For solution, I will take it as Pn, n plus 1 and n plus 5. Now it becomes easy to put the values of n. First step, put n equals to 1. Okay, when you take it as n equals to 1, P of 1 is equals to 1, 1 plus 1, 1 plus 5. That will equals to 2 and 5 and 1, 6. 2 and 6, that is 12. It is a multiple of 3, which is multiple of 3, right? That means the n equals to 1, true, result is true. This result is true for n equals to 1. Now the step 2, assume that the result is true for n equals to k. Assume that the result is true for n equals to k, right? When you take it as n equals to k, so we have this value k plus 1 and k plus 5. This is a multiple, which is pk, is a multiple of 3. So you can write it as 3m. That means it is a multiple of 3. So you can suppose it as 3m. M means multiple, 3 is given in the question. Okay, for finding the value, we have to find out k plus 1, that will equals to 3m upon k plus 5. I will find the value of k plus 1 to use it for the third step. Okay, where I have to use it, see, in the third step for proving the result for pk plus 1. When you substitute the value k plus 1 here, we have k plus 1. Here k plus 1, that is k plus 2. And here when you put k plus 1, it becomes k plus 1 plus 5, that is 6. So I will write directly 6. Okay, now it is the time to put the value by using the step 2. So k plus 1 has value 3m upon k plus 5. This will equals to k plus 2 and this will equals to k plus 6. Same as it is. Now the terms come with the multiple of 3. You can write it as which is multiple of 3. Right? This is the proof for k plus 1 term. This is right for the multiple of 3. After that you can write it as the result is true for n equals to k plus 1 and the result is true for all n. After this you can write it as the result is true for, this implies the result is true for n equals to 1, only k plus 1. Therefore, by mathematical induction, the result is true for all n. Result is true for all n. So this is the way. This is a very simple way as compared. It does not require more time. It is less time consuming as compared to the first type. Okay, come to the first one more question. That is of again from induction, and this is of polynomial. So how you can solve it? I will do the question for you. That is question number is induction. Question number, that is 20th. Question number 20th is 10 raised to power 2n minus 1. It has a power 2n minus 1 plus 1 is divisible by 11. Okay, is divisible by 11. You have to solve it. You have to prove this statement for 11. How you can solve it? There is no equality sign, so you have to take it as Pn. That means polynomial in the form of n. So I will take Pn. Pn is equals to, when you do the solution, Pn is equals to 10 raised to power 2n minus 1 plus 1. Okay, put n equals to 1. This is your first step. P1 is equals to 10 raised to power 2 minus 1, that is 1 plus 1, that is 11, which is divisible by 11. Okay, divisible by 11. That means the first step is true. Now come to the second step, that is assume the result is true for, result is true for n equals to k. When you have to take it as n equals to k, you just take the value of n is equals to k. Okay, so take it as pk, that is equals to 10 raised to power 2n minus 2n, that means 2k minus 1 plus 1. If it is divisible by 11, after dividing we have some quotient. Let us suppose the quotient will be m. Okay, when you take it as 2k minus 1 plus 1, it will equals to 11m. I want to find the value of 2k minus 1. For substituting this value for proving the step third. I need this value for the step third. That's why I will take the value, find out the value from the second step to use it in the third step. Okay, now it is the time to solve the third step. So what is the third step? I will use the step for, this is the value which I have left on the board because I will use this in the third step. Okay, so how you can simplify it? I have this value, this is the third step. You have to prove for k plus 1. When you want to prove it for k plus 1, we have 10 raised to power 2. In place of 1, there is k plus 1 minus 1 plus 11. Okay, I want to show it is divisible by 11. There should be some terms which that all terms should be divisible by 11. Though for that I will multiply it by 2k plus 2 minus 1 plus 1. I will take 2k minus 1 along with 10 2k minus 1 plus 2 plus 1. When the base are same, we can divide the powers like this. 10 square plus 1. Okay, now I have this value in the second step, that is here. I will put this value in this place. When I put this value, we have 11m minus 1 and here 100 is there plus 1. Now I will rub these two steps because I have that value, I have put that value in the third step. When you multiply it, when you multiply 100 with 11, this is 1100 m minus 100 plus 1. That is 1100 m minus 99. Now you can take 11 as a common factor, 100 m minus 9. This number is divisible by 11. That is 11 common factor is there, which is divisible by 11. So this is the way to solve this type of question. This implies the result is true for n equals to k plus 1 and true for all n. When it is true for n equals to k plus 1, so it is true for all n. Okay, so these three steps you have to learn. First is put the values for n equals to 1. Then the second step is you have to take the value for n equals to k, and third, for proving the third step, you need the second step solution, simplification of second step, and prove the third by using the second step. Okay, one more question. I will do one more question for all of you. What is that question? I will take the question that is very simple. Okay, I will take for your convenience, that is question number 21. 21 question. Maximum times student think about the variables, they confused about the variables, how we can solve the variables with power n. So I will do that question for all of you. That is question number 21. That is x raised to power 2n. You have to prove that x raised to power 2n, y raised to power 2n is divisible by x plus y. So you have to show that there is not a numerical value, these are the variable. So how we can prove? I will start the solution with, suppose it as Pn. I always take it as polynomial in the form of n. So I will take it as x2 raised to power n minus 2n, y raised to power 2n. Put n equals to 1. When you put n equals to 1, P1 equals to x, 2 ones are 2 and y 2 ones are 2. I will apply the identity, that is a square minus b square, a minus b, a plus b, right? Now this is divisible by x plus y. Write down which is divisible by x plus y. Okay, because there are two factors, when we divide x plus y, x plus y and x plus y will cancel. So true. First step is true. Now come to this is the first step. Now come to the second. You have to take the value, that is assume the result is true. So you have to take k, that is x raised to power 2k minus y raised to power 2k, that is divisible by x plus y, right? X plus y, when you divide it with x plus y, definitely there is some quotient. I will take it as m. X raised to power 2k minus y raised to power 2k is equals to mx plus y, right? Now I want to find either the value of x raised to power 2k or y raised to power 2k. It is totally of your choice which you want to put. I will take the value of x raised to power 2k. That will equals to m x plus y and plus y raised to power 2k. Okay, I will use this value for proving the step third. So I will start the step third. That is, what is that step? The step is very simple. I will take the step as it is. I will leave last line so that I will use this line for proving the step third. Okay, so I will leave the line on the board for your help, so it become easy for you to take that values. The third step means you have to put the value for k plus 1, right? For k plus 1, x raised to power 2k plus 1 minus y raised to power 2k plus 1. I will take the term like this. It become 2k in plus 1 2. Okay, minus y 2k plus 2. I will divide the powers into two form like this. If the base are same, we can add the power. If the power are added, we can separate the base also. Here we also separate the base like this. Okay. Now I will put the value of this x raised to power 2k. This value which I have got from step second. So I will take this value. This is mx plus y and plus y raised to power 2k. Okay. And with this we have x square minus y 2k into y square. Okay, now I will solve the value. I will rub the value from here so that I will solve this. Okay, so this is the first term is with along x mx square x plus y. This is complete divisible by x plus y. Now we have to work on these two steps, that is x square y 2k and minus y 2k y square. Okay, I will take y 2k common from this step. This is x plus y plus taking y raised to power 2k. We have x square minus y square. We have to apply the identity. What is that identity? Mx square x plus y 2k. We have a minus b, a plus b. Yes, I will take these two terms common. This is x plus y. In the bracket we have mx square plus y 2k x minus y. Yes, which is divisible by x plus y, right? It is divisible by x plus y. By clear this, the third step takes some time for solution. Okay, so you have to use the second step for proving the third step. Now you can write it as the result is true for n equals to k plus 1 and for all n. So by mathematical induction you can easily solve by using these steps. This is the way to solve the question. Do the practice of this type of question. Thank you.